Hello everybody, I will start my today's another coding practice. So today I will solve this question, split array largest sum. In this question, I'm giving an integer array nums and an integer k. Split nums into k non-empty subarrays such that the largest sum of any subarray is minimized. Returns the minimized largest sum of the split. A subarray is a contiguous part of the array. Okay. So in this question, I will take exactly, okay, I'm giving an integer array nums, and also I'm giving integer k. And firstly, I will split nums into k non-empty subarrays. So I can think of this just like I can split into k segments. Yeah. Then I will calculate the sum of each segment. Then I'd like to make the largest sum as small as possible. So I will split the array so that maximum sum of the segment is minimized. And I will return the largest sum in that split. Okay. So again, the input should be integer array nums and integer k, and I will return the integer sum. Minimum max sum. Yeah. Okay, so some edge cases I have to take care is firstly, the number of elements in the nums array should be at least k. Otherwise, I cannot split it into k non-empty subarrays. And I will take a look at the constraint, and I find that k is smaller than 50 or num strings. So if k is smaller than 50, k is smaller than num strings, so it's okay. And when num string is more than 50, like 55, k is 1 to 50, so still it's okay. Yep. So I can always split it into non-empty arrays. I could confirm it. Okay, good. So let me think of this question with some examples. So I will think of the case like this. So in this case, I split the segment into two. For example, if I split this into this way, 7, 2, and 5, 10, 8, in that case, the maximum of the first segment should be 7, and the maximum of the second segment should be 10. No, sorry. I will think of the sum. So it should be like this. Yep. So max sum is now 23. And let me think a few more cases. Obviously, I should have started from here. In this case, the maximum sum is 25. Yeah. I know two more ways to split this. Let me think. So, yeah, like this. Okay, so it works in this way. So I can say max sum is now 23 and 14 and 24. So definitely I should return this. So I should return 14. No, wait a minute. Minimize largest sum of the split. Oh, sorry, this should be 8. No, this should be 18 and 16. Sorry, so I should return 18. Okay. So this is the meaning of the max sums. And in this case, I had to split into only 2 segments, but k becomes larger and larger, so it makes the things a little bit harder, you know. Okay, so I think the brute force approach is that I will try every possible way of splitting, and then I calculate each segment sum, and I get the max sum. And for every split way, I get the maximum sum. So I return the minimum sum. So that's brute force approach. And I think the way I split the cell into k segment is that we're missing. So if I'd like to split the segment into say 4, all I need to do is put this, divider and original nums. Yeah. And for example, if this is sorted like this means that the nums array is split into 1 and 1 and 1 and 2 elements. Yeah. So basically, the number of ways to choose this divider is divider positions is n plus kck. Yeah. However, there's a limitation that I have to each segment has to have one or more element, at least one element. So this is not allowed, for example. So I can say the actual number of way is less than this. But yeah, so this is how I can split into the segments. And for each, I have to get the largest sum. Yeah. So let's say I traverse of the element to get each segment sum. Yeah. So in that case, the time complexity should be this. Yeah. Yeah. This is quite, much time. So I will think of the optimized approach. Okay. So I think the most intuitive way to solve this question is, okay, I've come up with 2 solutions actually. The first one is dynamic programming. The second way is using the binary search. So when I use a dynamic programming, I will, the sub problem I'd like to solve is like this. So I start from some cell in the middle of the nums. So this is the first thing I have to take care. Also, I'd like to think how many segments should I split into. Okay, so the subprogram is that I will think of the subarray, which starts from start index. And I'd like to split into, say, some number of segments. And I'd like to know the minimized largest sum. So this is a subprogram I'd like to solve. And once I can answer this question, this helps me to solve the larger question. So what I mean to say is, for example, if I decide to make the segment with only this first element, then my subprogram is I start from this number 2, and I try to split into k-1 segment, and I try to get the meaning of the max sum. Then I will compare that meaning of max sum with this 7. Yeah. So meaning of max sum is smaller than 7. This 7 should be the answer, but meaning of max sum is larger than 7. That should be the answer. So, and I will choose how many segments I should take from the beginning of each program. So let's think like the top-down dynamic programming. The recursion way. Yeah, recursive way. So in this case, firstly, I will decide how many elements I should take from the beginning. So there are k options. No, sorry, n options, basically, at max. Then I have to solve the, question with the remaining elements. Yeah. Okay. And the good thing is that I can do the memorization for this because for specific segment with specific number of, for the specific range, subarray with specific number of segments, once they're decided, the minimum max sum is always constant. Always, it doesn't change. So I can use the memorization. So in that way, I can say, firstly, I will quickly assume the time complexity. So the number of recursive, recursive function call is so n times k. Yeah, basically. Because I can start from each of these elements, there are n options. And also I have k possible, remaining segment count. So the time compressed, the function call should be n times k. And I have to take care that in each recursive function call, in each subprogram, I will choose how many numbers I choose as the first segment. So there are n options. So this means that in each recursive function, I have to traverse, I have to try n choices at max. So this is the time complexity. Okay. So now I will tell you about the binary search approach. So in the binary search approach, I will think of, I can always say max sum is between 0 to sum of the nums. Yeah, this is guaranteed. So, max sum, which means that I will think of, every possible way to split the nums array into k elements. And in either way, the max sum never becomes less than 0. And the max sum never becomes more than sum of the array. Yeah. Obviously, it can be more than 0 or it can be less than sum of nums. or I should say, it cannot be 0 or it cannot be sum of nums, but I can say upper bound, I mean loose upper bound and loose lower bound is these, I can say. So that being said, I will think of the max sum. Sorry, so my task is to find the mini in this range. Yeah, so I'd like to say if max sum is 0, it means that the okay. So let me say, let's say I'd like to know I can split the array with into k segments so that each segment sum is less than or equal to 15. If it is possible, I can say the mini of max sum is 15 or smaller. And I will try the game. And next I will try, I'd like to make the mini of max sum to be 14. So I will think if I can split the array into k segments so that each segment sum is less than or equal to 14. And if it if it is not possible, then I can say 15 is the answer. Because I could make it 15, but I couldn't make it 14. So that's how it works. Yeah, so I can use the binary search to find that. So I will try every max sum, you know. Let me quickly write it. Yeah. And I will find the largest, no, smallest sum upper with which splitting is possible. Okay, that's it. And I would say that for this time complexity should be, so doing the binary search, it should be log of some nums. Yeah. Times. I have to do this times. I mean, I have to do log some nums steps of binary search. And for each binary search, it will take O of n, because all I have to do is just take a look from the beginning and, you know, I will try to, you know, yeah, choose the new number while traversing into the current segment just as much as possible. Then if it goes beyond the upper, sum upper, in that case, I cannot include it into the current segment. I start a new segment. Yeah. So that's how it works. Yeah. Okay. So let me think which I should go with. So n to the power of k times n, or n times logs some nums. k is up to 50 and n is 1000. Yeah, I think this is quite large because this is 1000 to the power of, yeah, 50 in the worst case. Hmm. And for the binary search, sum of nums should be up to 1000 times 50 is 50,000. Yeah, so this is not so big. Log of, 50,000 with base 2 is not so large, and n is up to n to the power of 6. So yeah, let me go with the binary search approach. Okay, and let's just say. So my task is, okay, so I will define the helper function can split. So this takes the nums array and also number split and also sum upper sum. Yeah. So this returns the boolean if I can split into, splits yeah, nums array into the bounded segment. And I will try this once again. So this should be like this. At some point, the splitting is impossible. But once the upper sum is big enough, I can split in split. Because let's think the upper sum is very big. In that case, I just have to pick one segment each time. And for the last segment, I can put all of them. So yeah, all the remaining nums. So my task is to find the number which makes the can split, result to be true first. Sorry, I will find the minimum upper sum which makes can split result true. Yeah. So if I can split it, this is true. So I should be this. Otherwise, I cannot split. So I have to, take the upper sum larger than that. Yep. So this is it. Then here, it should be low is equal to high. And also, this should be possible. This is obviously true because if I take the, some nums, sum of nums, this is always possible. So I can find, yeah. In the worst case, the current row should be the sum of nums. Okay, and then I will return it. Okay, so now I implement the can split method. Okay, so what I should do is firstly, for each number, I will firstly check if I can put it into the current group. So in this case, I can put this current num into the current group. So group, yeah, I just have to do it. And if it isn't possible, I have to start the new group. So, but if current num is upper sum larger than the upper sum, yeah, sorry, let me do this case first. So in this case, I just have to create a new group. Okay. Otherwise, I will return false because current, current number is larger than the upper sum. So it's always impossible, obviously. Okay. So I will do it in this way. And in the end, I will return if current group sum is smaller than upper sum. I will decide the upper sum. Never try to see I can split it or not. Yeah, because if current, sorry, I will check group count is smaller than k. Yeah. So if group count is exactly k, this means that I could split. If group count is smaller than k, I just have to, split one group into two groups. Or, I just have to keep splitting until the group count becomes k, which means that I can, think of the way to split into k element with upper sum. Yeah. This is possible. Okay, this is it. So let me work through my code with my first example. Yep. So in this case, low is 0 and high is 32. So I have to do how many times? Maybe 5 times or something. Yep. Okay, so in line 52, I firstly guess the middle is 16. Then I will try to split. So in line 56, now middle is 16. So in line 64, this is called with this with k is equal to 2 with upper sum 16. Yep. Then the group count is 0, current group sum is 0. Then in line 69, first I will take a look at number 9. And current group sum, which is 0, plus num, which is 7, is 7, which is smaller than upper sum 16. So now current group sum is 7. Oh, I have to start from group count 1 because the first element should be included. Yeah. Wait, what should I do? The problem is for the first, number, it has to belong to the first, group. So let me do it in this way. No, sorry, let me do it in this way. No, I don't think this is a good way. So let me just move it here. Then I traverse from nums1. Okay. So, now group count is 1. Current group sum is 7. Okay. So current group sum plus num is okay. So and from the second element 2, current group sum 7 plus 2 is 9, which is more. Wait. I think this is one of the edge case. I have to take care. So I will return false if the first number is larger than upper sum. Yeah. So that being said, I go back to line 72 and I will take a look at num2. The current group sum is now 9, which is smaller than upper sum 16. Yes, the current group sum plus equal num. So now this becomes 9. Then I will take a look at number 5 in the next step. And 9 plus 5 is 14, which is still smaller than 16. So I can still, append this to the current group. Then the next element is 10. So obviously 14 plus 10 is larger than 16. So I take a look at the line 75 and 10 is smaller than upper sum. Yes. So group count is plus 1 and current group sum is now 10. Okay. Then I try to push 8, but this isn't impossible because 10 plus 8 is 18, which is larger than 16. So I go to line 75 and this 8 is smaller than upper sum 16, so it's okay. The group count becomes now 2. Oh, sorry, it should have been 2 and then now 3. Yep. So this isn't possible So now in line 81, k is 3, which is larger than group count 2. What do you mean? Yeah, so 3 is not smaller than 2, so I return false. So when false is returned, it comes here in line 58, and low is middle plus 1, so low is now, where is it? 17. And I will do it in that way. At least this is true because I'm looking for number 18. Okay, I think I covered most of the code. So still, I actually haven't confirmed completely, but let me submit my code because I'm pretty sure of this. Okay. Good. So I will submit my code. Okay, accepted. Great. So, yeah, that being said, I quickly wrap up my today's coding practice. So today's question was split array largest sum. So in this question, I'm giving an integer array nums and also giving an integer k, and I will try to split nums array into k segments, and each of them should be non-empty. And I will return the minimum of max sum. Sorry, I should be more, clear on that. So for each possible splitting way, I think of the largest sum of each segment. Then, largest sum of all the segments. Then I will return the minimum. I will think of the best way of splitting to make that maximum sum smallest. And I will return the minimum, such minimum of largest sum. Okay, so in this question, I thought of 3 approaches. The first approach was brute force one. Yeah, so I, think of every way of splitting, and I try to see the maximum segment sum for each case, and I will return the minimum of them. But this is not efficient. And also I came up with another approach, which I use the top-down DP. Yeah. So in this approach, I will think how many numbers I should take first, and then the remaining ones, I can, I will think of the sub-problem. Out of these remaining numbers, I will try to split into k minus 1 segment, and I will get the minimum of max sum for that segment. So with that answer, with that result, I can think of the larger range. Yeah. In that way, I can solve this question recursively. So this is a top-down DP approach, but I found that this is not so efficient either. So the final approach I came up with was binary search approach. So in this approach, I will think of the upper sum. Yeah. So I will think if I can split the array into k segments, if the maximum sum of, if the segment sum must be some upper or smaller. So if I give that constraint, I will think I can split it the array in a valid way or not. And if it is possible, it means that, upper sum, how should I say? It's quite hard to explain, but basically I use the binary search, and I will think of the sum upper, and I will try to make the sum upper, upper sum, as small as possible. And I will think of the smallest upper sum in which I can split the array in a valid way. Yep. So that's how I did the binary search. Okay. And in this approach, yep, in the can split helper function, I had to take care of some cases, especially when each element is larger than the upper sum. I have to immediately return false at that moment. That's what I have to take care. Okay, so I finished my today's coding practice with this. Thank you so much. Bye.